Hi everyone, welcome back to Cody's Lab. So in my video on carbonating honey part 2, I put some honey inside of a glass tube and put it under extreme pressure in an atmosphere of carbon dioxide. In that video, towards the end, many people noticed a bottle of compressed xenon gas. And I put that inside that video intentionally because I'm going to be working with this in, well, this video. So the idea here is to do something very similar, but instead of honey, have some sort of liquid and have the xenon gas be under such high pressure that the liquid floats on top of the gas. This idea actually was inspired by the BFG book that I read back in 2nd grade, in which one of the drinks that the giant enjoys is frobscottle, in which gas bubbles sink downwards.
It's facing the wrong way.
And I've always wondered if that would be actually possible, and if so, could I actually do it? So in order to recreate that, I'm going to be using, of course, an extraordinarily dense gas. Now, xenon is one of the densest gases that are non-reactive that I could reasonably obtain. Sulfur hexafluoride is almost as unreactive as xenon. It is denser at atmospheric pressure and quite a lot cheaper. In fact, this little bottle, which only contained about 25 liters of xenon gas, cost me about $1,300. So, you know, I've actually been putting off this video since April because I've just been getting up the nerve to actually open the bottle. But sulfur hexafluoride does have a few issues that makes xenon more desirable for me. So here's the vapor pressure curve of sulfur hexafluoride, and as you see, the pressure goes up exponentially with temperature, and at the critical point its density, which is a bit denser than some liquids I know, but is quite a bit less dense than water. Now it is possible to continue to pressurize it after the critical point and get something that is perhaps as dense as water, but the problem is this exponential. That curve continues up. In order to get it to a little bit more density, I'd have to have a lot more pressure. So if I were to increase the pressure enough to bring this density up above that of, say, water, the pressure would be probably way more than I could possibly contain with a glass tube. I might be able to do it with something a bit stronger than glass, but you won't be able to see it as well. So now if we look at the physical properties of xenon here, you can see it's a vapor pressure curve. It also goes up exponentially, but look at this. That's over 1.1 grams per cubic centimeter. That's denser than water. So we have a gas which is denser than water. It has to be under incredible high pressure. And at room temperature and pressure, there's not going to be any gases that are denser than any liquids. But at elevated pressure, we might be able to do it. And this is something I can reasonably contain. So, xenon it is. So you may have noticed that I've got a little glass tube set up here for the gas. I've got the neck down so it's easy for me to seal. But I'm using a much smaller glass tube than I was normally using for my other gases. You see, normally I'd use this thick glass here. But as it turns out, the smaller glass tubing is actually thicker glass proportionally, so it can hold more pressure. But most importantly, it's a smaller quantity of gas, so I can do many experiments on a tiny amount of gas. I mean, it's still, as is, going to cost like $10 an experiment here, but it's going to be far cheaper than it would be if I used the big tubes. Now I'll probably cut most of the actual making the tubes out because you've seen plenty of that in my other videos, such as the carbonated honey and sealing the supercritical CO2, etc. Okay, so here's the first one. It should be warmed up by now. I used a water on this first experiment because, well, if it works, I'll let this work for me. Let's pull this out of here. Hopefully it doesn't explode in my hand. Here we go. Let's have a look at this. I see my water is solid. It seems to have reacted with it somehow, which is weird for a noble gas because noble gases are normally unreactive. Let me zoom in on this a little bit. Okay, so here we go. Looks like there's some white material here and what looks like water that is stuck at the top of this thing. Can't seem to get it to move. This stuff here is kind of weird. It almost resembles ice. fact, I'm going to go look something up. This is definitely a chemical reaction that's happened with this. I want to see what the reaction might be. Be back in a moment. It's a clathrate! So xenon actually gets in between the water molecules and actually kind of sticks them together and causes it to essentially freeze. And so you get xenon gas incorporated into the ice crystals. Now, I've only ever really thought of this happening with methane, and probably at low temperatures and under incredibly high pressures, but apparently xenon does it just under these conditions, 60 atmospheres of pressure and room temperature. I've got solid water, which is weird. Like, hardly anything makes water freeze at a higher temperature. That's actually why I've got the sink running here, is I wanted to try something. If I put warm water through this, it should cause the clathrate to actually melt. And then I'll just get liquid xenon hydrate. And it is indeed melting it. Ah, that's cool. But unfortunately, this is not a liquid floating on a gas. In fact, the xenon makes it quite a bit denser, so that even though it's a solid, it's going to sink in the xenon gas. So this isn't going to work. Let's try something else. Perhaps oil? Wearing a jacket in the middle of summer was a bad idea, but it is good padding to stop the glass fragments. Anyway, I've got a sample of mineral oil that I've got with the xenon. Let's see how this looks. Okay, well, it's a liquid this time, but my God, it's half full. I only put a few drops of oil in there. Look at that. There was only a little bit of oil. Now there's a lot more liquid, and it sinks on the xenon gas. So it seems like the xenon has dissolved into the oil and has made a heavier xenon-rich liquid. That's interesting as well. I do have something that I don't think it will dissolve into or react with. Let's try some NaC. All right, let's see what we got with the NaC. So this is a alloy of sodium and potassium, so it has a very low density. Let's see what we got here. It's floating. Okay, let me zoom in on this a little bit. Okay, so you can see the blobs of liquid metal. Looks like they've got an oxide coating and they have a tendency to stick to the glass, but you just saw there, they floated upwards. If I turn it over, give it a little bit of nudge, it floats up the other way because the metal is actually less dense than the gas that's around it. This is a liquid floating on a gas, even though it's a liquid metal. Not exactly something that's drinkable, but there you go. Now, the NaC is really sticky to the glass. I think that's because of oxygen impurities that I had in this container. So let's try a smaller amount, so just a single small bead of NaC, and let's actually mix a little mineral oil and perhaps some isopropyl alcohol in there, just to help clean it. And that ought to give me 2 liquids, yeah? Okay, before we get to that, I just took all these out of the freezer, so we should be able to see, see the oil as I got the xenon boiling out. The water. Yeah, you can see the xenon gas, or the liquid xenon inside of the water container, and in here on the liquid sodium potassium. So you can see the liquid sodium potassium alloy will float on the liquid xenon, but it will not float on the gas that's currently in there, because a lot of the gas is condensed into a liquid. It's not dense enough yet. So the xenon gas is still boiling away, and then right there you saw that the sodium potassium decided to float up once the density got high enough. Cool. Okay, so over here I've got my NaC, or sodium potassium alloy, and I got a little bit of mineral oil here. I'm going to add in just a small amount of some isopropyl alcohol. This will keep the oxides and stuff from getting on the metal because, well, it'll actually react with it, leaving me clean metal. So just probably not a whole lot. You know what, as long as I keep it clean to begin with, I bet only 1 drop is all that's needed. Mix that in. So I'm going to take this treated mineral oil. I'm going to add just a small amount of it into the tube. Now to get a small amount of the metal alloy down in there. I'm going to use less than I did last time. So I'm just going to get just a small amount here. Alright, so there's the liquid metal down at the bottom with a little bit of mineral oil with it. Presumably that mineral oil will absorb xenon, but hopefully will remain enough gas to float the sodium-potassium alloy. Now I'm just going to swab down a little bit to clear the oil away from the neck. Base weight of 6.53 grams. Stick that down in the nitrogen. Just give it a little bit of xenon here. Just about 5 psi. And then I'll do that until there's a good amount of frozen xenon in there. Okay, so that number right there is the amount of xenon I'm looking for. 756, so that's 1 gram, so I actually need to let this evaporate just a little bit. Okay, what I've been doing is going away and watching something on YouTube, and then I come back, it's probably warmed up by now. So, let's have a look at this, shall we? Let's see if we got anything that's a little bit better. See that? The blob of metal is actually floating on top of the liquid xenon oil mixture and going up into the xenon gas. And it's not sticking to the glass nearly so badly. It's still kind of a little bit too big for the tube, so it is getting hung up, but it's like a little balloon. Actually, I wonder if I could shake this and break it up a little bit. Well, there it is after batting it around a little bit. As you can see, the pieces are broken up. It's because it is a liquid, even though they kind of look like solid. So I think I've shown that it is, at least in principle, possible to get a liquid to float on a gas. The liquid metallic alloys seem to be the best that I've tried so far, but it didn't really act like a liquid. It sort of tried to clump up, and when I shook it around, it just got some sort of coating on it and crumbled. So it didn't work all that well. So I'm going to try some ethyl alcohol. So I think this might actually be working. So you see there's a little bit of liquid here. So far so good. Oh, so weird. Okay, so there's liquid there now. Oh, it's mixed with it. Must have dissolved the xenon. It became heavy. Dang it. This is currently about 75% ethanol. So there's quite a bit more water in this one. Well, that's not the first one I've blown up. Okay, here we are again. It's got 75% ethanol, 25% water. As you can see, there's a little bit of liquid floating there on top of what appears to be gas. Let's give it a little bit of a shake and see what it does. Tip it sideways, maybe. It's having trouble making it all the way to the other side, though. Oh, that is cool. Look at that. Afraid to mix it too strongly. Where'd it go? Oh, it's up here. There we go. A liquid that floats on a gas. So the little bit of water in the alcohol actually made it work. Although, I haven't really mixed this up very well yet. Perhaps it will dissolve the xenon. Presumably it's got a lot of xenon dissolved in there already. That's why it's barely able to float. You know, it doesn't seem to be mixing in. See that? There's a bubble of xenon gas there. And watch as I tip it over. It sinks. Oh, it's so cool. So a little water was the key. I am so happy with this. So this has got to be one of the coolest things that I have ever done. This is amazing. Those bubbles are actually sinking. It almost looks like I've got oil on water or something, but it's a gas. I can cool it down and this will liquefy. It actually does this weird thing where the alcohol falls down and then sits on top of the liquid xenon, and then bubbles of xenon gas go up at the same time as globs of condensing liquid xenon fall through. It's really weird. And as it warms up, you can get to the point where you have gaseous xenon above and below the alcohol, and then liquid xenon below that. Oh, that's so cool. I kind of wish I would have dyed it green. In fact, you know what? So I did actually make some that was green. I also added a little bit of mercury here. So now you can see liquid, gas, liquid. When I turn them over, they switch places. So I've actually made frobscottle. I mean, this is... at least I've proven that it is in theory possible. Perhaps sugar might do the same thing that alcohol does. So a thick syrupy liquid such as soda might do it. But there's so many things that I could try with this. There's probably a lot of ways that you could improve this so that it's more fine-tuned. But I've definitely proven that it is possible. I don't think you could do this at normal atmospheric pressure though. Perhaps if you were down inside of a deep sea, one of those pressure vessels that they use for the divers that weld on oil rigs. Something like that you might be able to actually have a bottle of stuff, you can open it up and actually drink it. So yeah, there you go. So, hope you enjoyed. I'll see you next time.